So I think we'll have 3 or 4 speakers tonight. So for our first speaker, it's going to be Bawden. He's from Philippine, but although I'll let him do his intro. Yeah.
I'm from Philippine, but I wasn't born there. Can I ask you folks, can I go around this way, because standing behind me kind of makes me nervous. So basically I've got 3 talks for you to choose from tonight. None of them are Ruby specific. Last time I spoke to this group was about databases. I remember some of your faces, and it was about just because you've got an ORM doesn't mean you should ignore the database, right? Does anyone remember it? Yeah? No? Vaguely? Painfully? So I've got one called Bridging the Intentions Actions Gap, which is sounds impressive, it's not. But it's really about how we should concentrate on adding value to our customers, not necessarily messing about with things that are mundane and boring. The other one is about a thing called the Lambda architectural pattern. It's a data engineering pattern, like processing a large amount of data at scale. And I go on to a thing called data lineage, which is about looking how data gets processed and then eventually persisted. So there's your choices. There's one about DevOps, but DevOps. So bridging the intentions actions gap or the Lambda architectural pattern?
The second one.
Second one. So let's get hands up for bridging the intentions actions gap. No one. Right. So, and Lambda architecture? Right, 3, 4, and the rest of you want to go eat pizza. So I'll bring that one up then. Okay, so if this goes too long, someone just tell me to cut it off, because I know you've got 3 other speakers tonight. First off, thanks to you guys for having me back. It's good to be back. My name's Keith. I'm that one there down the bottom left-hand corner, which is at Bordeaux. That's where you'll find me on Twitter. I would not recommend following me on Twitter. I'm rather droll. Not much happens there. It's also how you'll find me on P-hackers or Fackers or whatever you call it here in the Philippines. By trade, I started out as a Unix engineer, hacking on anything Unix related, which was also networking. I did a little bit of, not hardware, but anything from rack mounting stuff in data centers or whatever. As a Unix engineer, these are the 3 best processes that I've been able to fork. They're mine. Once you've had kids, you know that you can now make your own humans, which is a nice thing to know. I'm from Flipper, as the shirt says. We are the world's largest online platform for allowing people or helping people to buy and sell digital businesses. So if you want an iPhone app, you want to actually own the iPhone plus the IP, not the iPhone, the app, sorry, or an Android app or a website, whether it be an e-commerce site or what have you, or domain names, go shop at Flipper and you might find something that tweaks your interest. We're hiring too. Don't know anything about Allogica. I'm sure you're a great firm, but we rock too. You can email me at keith.bawden@flipper.com, or the easier email to remember, which is keith@linux.com. I'm proud of that email address. It's quite nice. And then, as I said, Bordeaux on, is it P-hackers or Fackers? So we're a bunch of Fackers. Okay, I get it. Right, so today we're going to cover off the Lambda architectural pattern. This is not AWS Lambda. It's not the serverless architectural thing that's all the rage at the moment. It's an architectural pattern that came about in the 1970s in academia, and it's really only in the last decade that the pattern's been accessible to folks with a credit card. Now, what do I mean by that? Is because of things like Amazon, you can follow this pattern, like Amazon AWS that is. In the past, it was really only large enterprises that could probably benefit from the pattern, but as we know, most large enterprises are really old-fashioned and slow, and are still using VB running on Windows machines. Never mind this stuff. By the way, part of my intro, I should say, is this is a very AWS-centric talk. It's about a pattern, but I do give the examples in AWS Primitives. I used to work for Amazon. I have no shares in the company anymore, so it's not about that. Okay. I also work for Amazon, not Amazon AWS. As I said, it's not Amazon Lambda. It's a data engineering pattern. So why are we here at a Ruby talk? Because I think that this pattern really helps people to grok how to process data streams, how to do event sourcing or event-driven engineering. Anyone know what event sourcing is? Yeah, probably a couple of years. The pattern's a data engineering pattern, but you could also use it for almost anything that processes events. Now, I'll cover off what events are later on in the talk. But first, what's big data? Anyone want to take a crack? I know it's the Philippines and we're all shy when there's some guy talking and whatnot, but come on, someone give me a definition of big data. Someone be brave.
Billions of records.
Sorry?
Billions of records.
Billions of records? Millions of records? You look like you've got something to say, mate. What's big data?
I think it's a large data set.
Yep. But what's large? So we've just gone from big to large, which is cool. I'm not making fun. I'm kind of making fun of you. I'm sorry. So big data, and this is my definition. So don't Google it because it's probably crap. But to me, big data is if you've got data that's too big to process on one machine, then it's big. Right? Now you could be like a SAP and go out and recommend that your customers have a machine with 128 cores and 256 gig of memory and say, see, it fits on one machine. That's not really what I'm talking about. I'm talking about on a normal machine, right? Like you might have something with 4 or 8 cores and 16 gig of memory or 32 gig of memory, which is still a big machine, but you need multiple of those, and then you could say it's big data, right? It doesn't fit on a single machine. Data science, anyone want to have a stab at that?
Understanding we did it.
Understanding big data, yeah. Basically, for me, it's when you wear a white coat with a pocket protector and walk around using language that no other people understand. That's part of it. Data science is not an individual job title, I don't think. It's a role of a team. It's basically where you have a hypothesis. You've got a shed load of data. If I swear, my apologies, I'm Australian. So you have a hypothesis, you've got some data, you run some experiments on top of the data to support or not your hypotheses. And then you just iterate over that. Out of that you may learn something from which you can create an algorithm or something like that to run over your big data to recommend which Netflix videos folks should watch next. So, sorry for the small font and the really crappy slide. If you squint, you probably still can't read it. So I'll talk you through it. The history of this slide is I actually ran a data science team in Amazon for about 3.5 years. It was great. I had no idea what I was doing, so I hired folks that did. And what I found was, in that team, we would spend about 20% of our time acquiring the data, right? Going out, actually finding the data. Now, who here has ever seen a clean data set? Yeah, laughs? No. You don't really see it, right? So then you spend 50% of your time cleaning the data, transforming it, cleaning it, maybe enhancing it by getting other data and adding it to it. And then we'd spend 20% of the time storing the data. That doesn't mean that we spend 20% of our time injecting data into databases, right? What it meant was we'd spend 99% of our time trying to come up with the best schema for persisting the data, choose the best type of persistence engine, whether it's Cassandra or Redis, sorry, not Redis, or what's the Amazon Redshift or whatever. It was really that thinking and then just implementing it, right? But there's a lot of time thinking about that. We'd spend 2% of our time exploring it. Exploring big data is hard, right? You write a query, it takes 3 hours to get back, and you're like, oh, God, there's a mistake in my query, right? So the ability to explore data at speed is super important the bigger you get. Then we'd spend 3% of our time experimenting. You get your algorithm from your hypotheses, you apply it to the data, you inspect the results, you iterate. Again, on big data, that can be slow. Then you spend 5% of your time. That's you get the output of your algorithms, and then you create models, whether they're forecasts of the future or trying to fit what would have happened if we had made a different decision, or making different scenarios, or you It could even be, like I said, a recommendations engine around trying to recommend a purchase for a customer. Then the last part is what I call either distributing or re-vending the data. So you've got your data, you've processed it, you've then stored the insights or what have you that you've discovered, and you want to give people access to that. It could be via a pretty graph, or it could be just an endpoint for which people can poll for data. Right? Not a really good spend, right, of your time. You go out and you hire some mathematicians and some statisticians, and they're only sitting around doing a little bit of work, right? Because the tooling isn't helping them. So the data pattern that I'm going to show you today helps to kind of alleviate that. Helps you to be able to process massive data at speed and then also query it at speed. Now that this is a pattern, it's not an implementation. So I've given this talk before. I get all these questions about, oh, I've got this problem, how would you do that? I'd say for a couple of grand a day, I'd give you a hand. No, just joking. I'm just saying that this is not an implementation. This is a pattern, okay? But I'll try and help with those type of questions if they come up. So that's the pattern. So that's the end of the speech. Thank you very much for coming. Pretty much with that, you are now forewarned and forearmed. Basically, it starts off on the left with an immutable data store. I'll go on what is that next. Then we have a layer here called the batch layer. Then there's a box directly below it called the speed layer. And then we've got these two other boxes called the serving layer. That's the distributing layer I was talking about before. And we've got a query coming off the end here, which is pulling data out of both layers. Okay? Now, what comes next? Right. The immutable data store is an append-only time series data store. Right? This is not for qualitative data, right? You're not just going to put, say, tweets in there unless they're time-stamped. Yeah? They've got to have timestamps for this particular model to work. Right? This is really just for time series data. Let's face it, most interesting data that we work in the Rails world is typically time-stamped anyway, right? When did something happen? And that's why I was talking about events the other day, earlier on the talk, right? So you've got an event, something happened, and there's a timestamp. You throw a copy of that event into a data store, and you write once that's it, right? So it's append only. That means if you put a mistake in the data store, you don't delete it, you put a correction in there, right? So if I said that you did something, like you spent $20 on the platform, and I say Bob at 10 o'clock spent $20, and we found out that that was a bug and Bob did not spend $20, we would put in a reversal. Bob at that time plus, say, 1 second minus $20, and that would get Bob's state back to where it should be, right? So you don't reverse it. You've all got telephones, I suppose, I'm hoping. Yeah, good. Or not, whatever floats your boat. At the end of the month, you get an invoice or a bill or what have you, and it has line items, right? It just doesn't give you a total. It gives you all the line items of what you've done, and then you can total that at the bottom. Think of each line as an event. Yeah? To make this a little bit more Railsy for you, most Rails applications are just good old-fashioned CRUD, right? And I don't mean crap. Having said that, if you see my Rails code, it's pretty cruddy. But basically, the problem with the CRUD model is every time you update or delete, you're actually destroying data, right? So if I said that you had $12 in your bank account, and then I went and updated it and said you've got 10, I've destroyed the fact that you used to have $12 in there. Does that make sense? Rails, by default, and the way we normally code in Rails, is basically we just maintain state for the current state, right? We don't maintain the historical state of how we got to where we're at, yeah? But you can do it in Rails 2 as well, and I don't mean Rails version 2, God knows what you can do with that, but anyway, basically, I believe that when we're engineering, we should keep a cruddy monolithic Rails app there, and keep that state, but you should also probably fork a copy of the events and just go store them somewhere. Trust me, if you start doing that as a Rails developer, you'll be ahead of the curve. About 95% of other Rails developers won't be doing that. But also, next time you have a problem with a customer's current state, you'll be able to go back and say, oh, that's how they got to that state. Okay? Really, really valuable to do. But anyway, I digress. The batch layer. Now let's pretend we've got 10 years of e-commerce data in a big honking data lake, right? And it's very, very rich, and we want to do a forecast off that data using all of the 10 years worth of data. That forecast is probably going to take a long time to crunch, right? You're going to get all the data, you've got to start doing stuff on it, making some decisions, and then spit out a number, right? And you can scale up and have like 1,000 Hadoop nodes in AWS or somewhere else, or in Azure you could have 1,000 crashing Windows nodes, and still trying to process stuff, but whatever. You've got all these nodes, they're processing, and it might take an hour, or it might take a day, or whatever. It's a batch operation, right? The batch layer is slow, but accurate, okay? It's really important. The batch layer is slow, but accurate, yeah? The speed layer, on the other hand, it's got access to the last forecast. I'll use forecasting as an example, but that forecast might be 10 hours old, right? Or 12 hours old, depending on how long your batches are. Because remember, we've got the batch layer. Batch layer calculated something and stored the results. You can use those results, and then every time a new event comes in, you can add that event on the end of that forecast and just continue to forecast, right? It's very, very fast, but it's less accurate, right? So fast, but less accurate. Is it making sense? Yeah? And then as the batch catches up to now, what you do is you delete all of the data in the fast layer, the speed layer, and then start again. So the speed layer database is always small, right? The maximum amount of data in there is typically the size of a full batch. In time, that is. The serving layer is the layer that you allow other services or other people or what have you to access the output of the batch and speed layer. Okay? I'm going to have another picture on there that will make that a little bit clearer. Basically, it's the part at which people can access the data. Okay? So, the problem with this pattern is it's really complex, right? It is complex. But, like security, it's inconvenient, right? Handling massive amounts of data is just not easy, right? Handling lots of data on a single node, super easy, right? Handling it on more than one node, straight away, you're orders of magnitude of complexity. So this is complex. You'll have two different code bases. In the batch layer, you might be using R and, say, MySQL or whatever, to process the data, right? It'll be very slow because R is slow. Anyone programmed in R before? Yeah. It's my favorite language to hate. It is a great language, but it is slow. You've all heard of R, right? Yeah. Have you heard the story about the best thing about R is invented by statisticians? And the worst thing about R is it was invented by statisticians? It's really hard to use, it's pig slow, but it's really, really accurate, really good. So in batch, we're doing stuff with R, for example. Down in the speed layer, you might have re-implemented a similar algorithm in something like Go or C or something like that, something really, really fast, right? But again, it's working on less data, very fast, and it'll be giving out slightly different levels of accuracy. So you've got two code bases, probably written in two different languages, probably trying to come up, well not probably, they'll be coming up with the same types of outputs, but derived typically through different algorithms. So you've got two code bases to maintain. If you change one, you've got to make sure the other one is also changed. It's called Lambda because it comes from, and now don't quote me on this because I'm not a mathematician, but it comes from the mathy version of Lambda, right? Or the functional version. Any Haskell programmers here? They don't get out much, so I don't expect to see any. Anyway, in functional programming, in a function, given the same inputs, you should get the same outputs, right? However, if you've got a bug, you've got to fix it, and that will change your outputs, right? So, with the Lambda pattern, if I've grabbed some data and I've processed it and I throw that data downstream, and then I find there's a mistake, I just delete the downstream data, fix the bug, reprocess, and move on, right? Who here has ever helped fix corrupted data in a Rails application? No one? Really? No, surely. Right? Every time I touch Rails, I break the database. And And then you've got to go in, and because we didn't maintain state, we've got to know how do we fix it. So what do? You go and try and inspect the bug to say, oh, how is it broken, right? Meanwhile, more errors are still coming in because you're researching the bug, right? Then you realize, oh, it's typically off by 20%. So you go back to the database and you take 20% off all the numbers, but you haven't fixed the bug, so all new data's still got the problem. And then you've got to go, oh, from where is it fixed and where is not it fixed? At least this is how I fix databases. And so you've got all these corruptions and stuff. But if you try to fix the bug first, then you're saying, I don't want to receive any more data until the bug is fixed and I deploy, and then I'll go back and fix all the data. It's a complete nightmare, right? In the Lambda pattern, you just sit there and go, okay, I'll delete the data. Cool, you delete the data. It doesn't matter, you've got immutable data up the front. Fix the bug, reprocess, restore, you're good to go. The maximum amount of time that it will take you to recover from data corruption is the amount of time it takes to research and patch the bug, the amount of time it takes to delete the data, and let's face it, that's fast. We've all done a sudo rm minus rf slash, not dot slash. So it's fast. And then it'll take the same amount of time as it took to run the batch in the first place. That's it, you're done, right? Do the same thing in a normal Rails database and it could take you days. Like literally last time a team that I was in did this, it took 7 days to recover from a data corruption. The last time we had a data corruption in the Lambda thing that was of the same kind of, or the same type of problem or complexity scale, it took a couple of hours, right? So 7 days versus a couple of hours. You can optimize for each layer, right? So down in the speed layer, right, I've got less data. So what I'll do is I'll use more money to buy really fast stuff, but I can still keep my costs down because I don't have two petabytes of data to process at speed. I might only have 2 gigabytes of data, right? Up the batch layer, I've got 2 petabytes or exabytes or whatever of data. So you'll spend less money as a ratio of each gigabyte, and you'll optimize for accuracy, not necessarily speed. So you can balance the cost profile of each stack, but you also can use different technologies, okay? Here's an example. That's about as artistic as you'll get from me. This is a very poor example of how to implement the pattern, because I was kind of in a hurry. Who's heard of Kinesis? Just hand wave would be nice. Yeah, one. Right. Who's heard of a message bus? One. Yeah. So data stream. Getting there? Yeah. Okay, cool. So I'll explain it anyway. There's a stream here, and I'm a piece of data. Okay. And I'm in the stream, and I'm going, what's your name, mate? Sorry? Romel? So Romel here is the invoicing system. It's a piece of software. His job is to get data and generate invoices. So I'm chugging along down this stream, and Romel gets a copy of me and starts generating an invoice, right? And then I go on down. What's your name, mate?
Eddie.
Eddie? Eddie is doing fraud detection, right? So he gets a copy of the exact same data, and at the same time, or relatively the same time, he starts doing fraud detection analysis on the same piece of data, right? And then off I go, and there's all these different consumers taking a copy of me and doing whatever they will with me. Hopefully it's nice. So that's one way of it, right? The other way of having a data stream is where you're chugging along, and Romel doesn't take a copy of me, he actually takes me off the stream, right? So we've only got one consumer in that state, yeah? And there's sometimes you want to do that because you don't want more than one thing processing the same amount of data, right? In that previous example, I had 2 or 3 things processing data, but they're all doing different things with it, right? So Romel's taking me off, I'm sitting on his lap, we're getting all cozy, and the stream now doesn't have me in it anymore, right? So they're the 2 basic types of streams we can have. Kinesis is a piece of software on Amazon that allows you to do that, okay? And it's pretty cool. This is what I was saying before, these patterns couldn't be done 10, 15 years ago by startups, right? Because you couldn't afford the software to do it, yeah? Anyone ever worked with a product called RVRD? It's a rendezvous product. It's a massive, large-scale message bus kind of thing. Worth a ton of money. We're talking hundreds of thousands of dollars. It's not cheap, right? Startups couldn't do it. But now you get a credit card, you can use Kinesis. So Kinesis allows us to stream data like that. So I just spent that time to explain it to you so the rest of the downstream diagram will make sense, right? So I've got data flowing in here into Kinesis, and I've got two consumers of the data, right? Down here, this EMR thing is an Amazon product called Elastic MapReduce. It's a pretty bad name for a product. It used to allow you to run Hadoop at scale, and Amazon would handle all of the Hadoopy stuff, like spinning the clusters up and shutting them down and stuff. But now you can run more than just Hadoop in there. You can run Spark. I think they've got Presto and Druid and other stuff that runs in there, but you can definitely run Spark, and you can definitely run Hadoop in there, of course. Hadoop pretty much does MapReduce and not much else, and Spark does MapReduce and a whole bunch of other stuff. But by the way, if you're using Hadoop, to do some research, kill it off, use Spark would be my recommendation if you can. So anyway, this thing has slurped up the data, and it's processing in micro batches in this particular example. Micro batches is just where you might say, I'm going to collect data for 20 seconds and then I'm going to process it, right? Or I'm going to collect 1,000 events and then I'm going to process it, right? So you're either setting your batch by time or your batch by event counts or some other mix thereof. But either way, I've got 1,000 events, right? And I make a prediction. Yeah, this shopper wants to buy a tennis ball, right? At least from these 1,000 events. You might use some of the historical outputs. We say, we know this shopper typically likes sports goods, this, that, the rest of it, take them as input. Given the events that person's been doing, we now believe they want cricket bats. That's a speed layer thing. You can see how that's going to be less accurate, right? Because it's micro batching with less data, and therefore you're going to get less insights out. Then we shuffle that data off down to Amazon's product called DynamoDB. DynamoDB is quite expensive to use, and it's very fast, right? But we're only going to be storing a couple of hours worth of data in there anyway, and we'll be deleting it. Now, if a couple of hours worth of data is 2 gigabytes, your bill should only ever be the 2 gigabytes of data plus all this really magic stuff when trying to figure out how much DynamoDB costs you, because it's not a simple function of just data size. Anyone here use DynamoDB? It's a thing. So it's a thing, but it's fast and it can be expensive. So we're using expensive stuff down here, right? Now we got to the batch layer. That was the speed layer, and we're serving it via Amazon DynamoDB. The top layer up here, I've got a thing called a Kinesis enabled app. It's just a little piece of software that you can write. They've got an SDK that allows you to pull data off a Kinesis stream. And then I'm storing a copy of it straight into S3. Right? There's my immutable data store. I've sent one copy down here, and I sent one copy to S3. And I'm making it write only. Yeah? So write once only, I should say. Anyone here write Perl code? Perl? Software programming language? Yeah. I also call that a write once language, or a write only language. It's not really rewrite. For those of you that have ever written Perl before, have seen my Perl before, it's crap and therefore not readable, so you only write it, I don't read it. So that's the same thing. You write the data there once, you're done. Then you might have a trigger or something that then has a MapReduce here or something running on all of the data in this immutable data store, right? Now that thing might have 10 years worth of data. Now you'll know you've got 10 years worth of data, you've got some cluster of machines here slurping up that data, crunching on it for a couple of hours or whatever, and then storing the results of that down into Redshift. Yeah. Redshift is, you can scale Redshift, you can make it faster by paying more money, you can slow it down or whatever, but you can control the cost just as you can down here, but it's typically cheaper. A terabyte of data up there, last time I looked at the monitor, there's something on there. It's about $1,000 US a year for a terabyte of data, so it's pretty cheap compared to Dynamo. Then down the end here, we've got something that can query both, right? So you've got all of history's insights in there up until 5 hours ago, because your batch is 5 hours old, right? Here you've got all of the last 5 hours worth of insights minus 1 or 2 seconds, depending on how big your micro batches are and how close to real time you are here. So you've got 9.999999 years worth of stuff here, and you've got 0.00001 worth of data here. So if you did a select, you'd get a lot of data from there, a little bit of data from there. You can join the two, and then you can have a complete picture. Okay? Does that make sense? There is a product called Presto. Presto. It's not an Amazon product. It's made by Facebook, and it is an amazingly cool product, and you can use it for this sort of stuff. What Presto does is, I'll go off a little bit of a segue. You write a query. It'll go down to different databases. It'll go down to CSV files. It can go down to some Oracle DB, some SAP things, some DynamoDB, Redshift, whatever. Go down, get the data, bring it back up into a common format, process it for you, and give the answers. It's a really, really cool tool, and it works lightning fast. That's that part where I said you want your engineer, your data scientists and whatnot, to be able to explore the data very quickly. Right? So a tool like that will help. So any questions with that screen there? No? No compliments on my stream analogies? No? Okay.
Can you give us like the application that you did this for? Like what answers were you trying to get? What was the...
So the last time I used this pattern or a similar pattern was for, and I can't give you all the details because they're NDAs and whatnot, is fulfillment center labor management data. So fulfillment centers are what we call, not we, I don't work there anymore, it's what Amazon calls a warehouse, right, where you pick and pack stuff. Now they had about 130 warehouses around the world at the time, and tens of thousands of employees. And every time you buy something from Amazon, a human will touch the thing you bought. Right? That's a bit icky, but there will be a human that will touch your stuff. Right? So say you bought a cricket bat. Someone will go along, scan that cricket bat, they'll throw it in a box for you. That was an event. The box will go on down, another human will pick it up, have a couple of practice swings for you, scan it and put it somewhere else. That's another event. So you end up with thousands and thousands and thousands of events per second of all the activities going on. We had a system that would slope up that data and look for trends in the data for how we can optimize the system. So for example, you might find, and this is not real, again because of NDAs, you might find that 7.5 minutes before morning tea in the Glasgow fulfillment centre, you'd see a massive drop in productivity, right? All the Scotsmen and women having a bit of a tea outage just before tea, and then you might see a bit of a perk up before it, so you might want to shift the tea break, right? To make sure that their caffeine fix is supported earlier on in the day than later. In the American warehouse, you might discover a different thing, but around their coffee breaks or their lunch breaks or what have you, right? Different warehouses, different cultures, different whatevers, you may have different insights. Long story short, massive amounts of data flowing in near real time. You scan it, boom, it's in that system, right? You scan something, it's in there, it's being processed. Another one was shipping decisions. It wasn't something that I wrote, another team wrote it, we wrote something else in the same kind of space, but boxes will be going down a conveyor belt. And when you buy something and it says, we're going to get it to you on the 12th of June, that's a promise, Amazon will make a decision as to how it'll get to you, right? Do we send it by Royal Post or do we send it by UPS, right? Typically it'll be which one will be the cheapest way to get it to you on that date. Every time that box gets scanned, that decision gets checked if it's still accurate. So if the system has detected that Royal Post has a problem, it might reroute it down UPS, and Amazon will actually make less money on that shipment because they believe getting it to you on time is more important than making that extra money. They actually do think that way. It's not me just being a sales pitch guy. They really do care, and they want to get it to you on that date. That's why internally they call it a promise, not a shipping estimate. Right? So those kind of systems is how you would process that. Just to give you a hint, it was 2013, I left in about 2014 or 13. At peak, there was about, and this is, you can Google this, so it's not something I can't tell you, about 320 items sold per second, right? 320 items sold per second. That's a lot of picking, packing, shipping, putting stuff in boxes, putting on trucks, all that kind of stuff. It's also a lot of searching on the retail place. There's a lot of stuff happening to make sure that you're selling 420 odd items per second. If you had chosen the other presentation, I would have told you how I broke fulfillment in Europe for 3 hours. But maybe that's one for another day. Now, that's the end of the Lambda architectural thing. We can call it quits there and give time to the other speakers and a little bit of QA if you want, or we can go on to data lineage, or I can cover that a different day. Up to you all to make that decision. Who's the organisers? Because I don't know what time it is.
I think we have time for Q&A.
Okay.
Yeah.
We're hiring. We're looking for a lead engineer, software engineers, and a DevOpsy/infrastructure guy or gal. Yeah, gals. Questions? Where do I apply?
I have a question about the grading both the server.
Yep.
What's this?
Speed and batch.
Server layer. What service like
Serving layer.
layer. So when you do query, you only query once and it will be sent to both.
Depends. Again, that's an implementation detail. You can write it yourself. Like if you know one's in MySQL and the other one's in Postgres, you have a little piece of software that will take one query, send two queries, one to MySQL, one to Postgres, bring the data back, join them, process them, and spit it out. Or you could use something like Presto, which will do that stuff for you. Right? We wrote our own. That's what Amazon does. But I would recommend, if you're going to look at this, and even if you're not looking at this, if you've got a lot of data, just go look at Presto. But yeah, basically it'll do that. So, and you don't always have to join the data. You might just do a union. You want to know the union keyword in SQL? Pretty lame. It just says get that data, and put them on top of each other. It doesn't really do much else. It just literally says, and that's a union. You can do that. You can say, give me the fast data, give me the slow data, and just put them on top of each other. You can do that in code, but then you know I could. Or you might actually get the two, make a decision between the two, meld them, do some magic on them, and then spit out a single data set from there. Yeah. Did that answer your question? Yeah. Anyone else? No? Awesome. Well, thank you. That's it.